This graph shows the different species of humans, when they lived, and how long each species endured. For example, Homo erectus remained on Earth about 1 million years, so we still have 800,000 more years to go if we want to catch up. Perhaps you've heard some people say, "I can't believe we came from monkeys." If you know people like that, please tell them they're right. Man did not come from monkeys, and the reverse is true. Monkeys did not come from man. We are all survivors, branches off of a family tree that has existed for 3 billion years. Monkeys are only one particular branch, and the branch point where they diverged is about 25 million years ago. This graph shows genetic similarity between humans and other selected species. All humans are separated genetically by only 1/10 of 1%. So only one base pair of nucleotides in 1,000 separates you from being Brad Pitt or Angelina Jolie. The DNA of chimpanzees, who branched off 6 million years ago, differs from human DNA by 1.2%, while gorillas, who split off 2 million years earlier, differ from humans by a slightly greater amount. Their DNA is 98.4% similar. At the other end of the spectrum, mice differ by about 15%, chickens have a 75% similarity in DNA, and even a banana tree shows a genetic similarity of about 60%. In other words, all of life is connected by common ancestry, and the differences in DNA are explained by the time of divergence. Also, certain genes are conserved through time, or life itself wouldn't be possible. Turning our attention to our own immediate forerunners, we come to this fellow who I think you will admit doesn't look very human at all. And whether he is or isn't is open to debate. Living just earlier than 6 million years ago, Sahelanthropus jidensis is still primarily in the ape category, yet an early member of the human family tree. Although Australopithecus afarensis usually is considered in the direct line leading to modern humans, Africanus, pictured here, does get a few votes. Their feet were longer than forerunners, and arches developed for better support of their bodies. Hands became more adept at carrying and handling foods and tools. While the late Australopithecines were similar to later humans, anatomically below the neck, their heads were significantly different from ours in several key features. Their adult brain size was about 1/3 that of members of our own species. The widest part of the skull of these early humans was below the brain case. For modern humans, it is usually in the temple region. They had comparatively big molar teeth and thick enamel. By comparison, their front teeth were small. They had large jaws and powerful jaw muscles. Paranthropus boisei males weighed about 110 pounds and stood about 4.5 feet tall. They had a skull and teeth highly specialized for heavy chewing. The back molars were large, with an area over twice as great as modern humans, and enormous cheek teeth averaged 4 times the size. The species is sometimes referred to as nutcracker man because it has the biggest cheek teeth and the thickest enamel of any other human species. The Paranthropus group lived in the same general locale and during the same time frame as the Australopithecines, but reached an evolutionary dead end. Eating roots and tubers and grass doesn't require the skills needed to hunt animals for food. Small family groups with little or no verbal communication would be sufficient for these vegetarians. For the hunters, though, larger groups would be necessary to track and trap wild animals. Some communication would be useful. Perhaps also members of the Paranthropus group were menu items for the meeting Australopithecines. Whatever the reason, it is from the Australopithecines that the genus Homo descended. The earliest use of stone tool making dates to 2.6 million years ago with Homo habilis, also called handyman. Evidence of this was found in the Middle Awash Valley in Ethiopia, where sharp flakes and stone cores were discovered. These cores exhibit overlapping scars where they were struck to produce flakes that were used for various purposes, such as scraping meat from animal bones. Homo erectus survived longer than any other human species, over 1 million years, from about 1.9 million years to 140 million years ago. Early African Homo erectus fossils are the oldest known early humans to have possessed modern, human-like body proportions, with relatively longer legs and shorter arms. These features are considered to be adaptations to a life spent on the ground, indicating the loss of earlier tree climbing ability, with the added capability to walk and possibly run long distances. The most complete fossil individual of this species is known as the Turkana boy, a well-preserved skeleton dated to around 1.6 million years. Microscopic study of the teeth indicates he grew up quickly at a growth rate similar to that of great apes. There is fossil evidence that Homo erectus cared for old and weak individuals. Their appearance in the fossil record is often associated with the earliest hand axes, the first major innovation in stone tool technology. Generally considered to have been the first species to have ventured beyond Africa, Homo erectus is a highly variable species that spread over 2 continents. Homo heidelbergensis is generally considered to be intermediate between erectus and modern humans living from 700,000 years ago to about 200,000 years ago. This early human had a very large brow ridge, a larger brain case, and flatter face than older early human species. Heidelbergensis was the first human species to live in colder climates. Their short, wide bodies are considered to be an adaptation to conserve body heat. They lived at the time of the oldest definite control of fire and use of wooden spears, and was the very first early human species known to routinely hunt large animals. This early human also broke new ground. It was the first species to build shelters, creating simple family dwellings from wood and rock. Neanderthals lived from about 200,000 years ago, surviving to about 28,000 years ago. Neanderthals are our closest extinct human relative. Some defining features of their skulls include the large middle part of the face, angled cheekbones, and a huge nose for humidifying and warming cold, dry air. Their bodies were shorter and stockier than ours, another adaptation to living in cold environments. But their brains were just about as large as ours and often larger, proportional to their heavier bodies. Males averaged 5 feet 5 inches in height, while females averaged 5 feet 1 inch. While the tall, lean bodies of earlier human species like Homo erectus were adapted to tropical temperatures, the short, stocky bodies of Neanderthals were adapted to winter climates, with thick, shorter lower arm and leg bones, making up a very strong and compact body. Neanderthals were more heavily built than modern humans and were more efficient at conserving body heat, allowing them to withstand living in cold climates. Neanderthals made and used a diverse set of sophisticated stone and bone tools. They controlled fire, lived in shelters, made and wore clothing, were skilled hunters of large animals, and also ate plant foods and occasionally made symbolic or ornamental objects. There is evidence that Neanderthals deliberately buried their dead and occasionally even marked their graves with offerings, such as flowers. No other primates and no earlier humans had ever practiced this sophisticated and symbolic behavior. DNA has been recovered from more than a dozen Neanderthal fossils, all from Europe. When Neanderthal DNA was first recovered and only a small portion had been described, it was thought that no gene flow or mating had occurred between them and our own species. When a complete DNA sequence had finally been obtained only a few years ago, it was discovered that from 2 to 4% of the genes from those of us who are of European and Asian descent are common to both species, indicating that some contact occurred in the areas where Neanderthals were prevalent and where some of our own species had ventured. The romantics among us might prefer to believe that a sort of love-in took place between them and us, but a more likely scenario from what we know of human tendencies is that hunting parties of Homo sapiens would encounter settlements of Neanderthals, eliminate the males and appropriate the females and perhaps the young children, thereby adding Neanderthal genes through procreation to their own genetic makeup. Whatever happened, we do know that peoples today who are native to Europe and Asia can boast about their Neanderthal heritage.